Yesterday, I got you all to write down on little yellow pieces of paper how many hours MSci 110 students, or how much you spent working on Blackboard this week. And so we collected 2 samples of size 5, and in fact I did my sums wrong, and the mean for one was not what I said it was something else. Actually, I've got it down here somewhere. Okay, so these are our samples from yesterday. So the mean of the first one was 2.9 and the mean for the second one was 3.4. Okay, so we got these 2 samples, each of size 5. Okay, now 5 is a very small sample, so you would expect things to be quite different between them. And can anybody tell me, there are the 4 kinds of error, what kind of error is causing the fact that the 2 means were different? Okay, you've got a choice of natural, bias, sampling, or explainable. Which one? It's sampling. Okay, there is natural variation, that's why you'll get things different, but the reason those 2 means were different is because of sampling error, because we took 2 different samples and samples will be different. That's just part of the whole thing. Because we haven't taken the population as a whole, the different samples will give different answers. So that is sampling variation or sampling error. Okay, so from those we're trying to estimate the answer to the research question, which was how many hours do MSci 110 students spend, blah blah blah. So in the first sample we could say we are 95% confident that the mean number of hours MSci 110 students spend working on MSci 110 on Blackboard lies between, I should say per week, so in there somewhere, this week I guess, lies between negative 1.6 and 7.4. Okay, well that's just stupid, because clearly nobody's going to spend negative 1.6 hours on the Blackboard. But that happened because it's a small sample with quite a wide variation, so we end up with this really big confidence interval. And in fact, from that, the true mean actually could be 0, but we just don't know it. Now here, the second sample, we're 95% confident that the mean number of hours, blah, 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 lies between 2.7 and 4.1. So that's a different confidence interval. Okay, so which one is right? Well, the answer is they're not right. You don't know, and that's the point. That's the point, is that we're 95% confident. Okay, so how confident is 95% confident? How many times out of 100 are you going to be wrong? 5. That's what it means. Okay, are you happy being wrong 5 times out of 100? Well, maybe not. Maybe you only would like to be wrong once out of 100, in which case you would do a 99% confidence interval. And what do you think would happen to these numbers if we wanted to be making sure we never ever missed, or as little as possible missed it? Would these numbers get further apart, or would they get closer together? They will get further apart, because we're making it further and further apart, so we can't possibly miss what the population mean is. So in instances when we're trying to find out about things, we can only ever estimate the population because we don't know about it. That was one of the things that we were talking about yesterday.